Hey guys, hope you're all well. I would normally be teaching you for our long Thursday morning session today, but don't worry, we'll still be able to do some stuff with sequences and series. If you haven't noticed, I'm up here in the corner, so it's nice to see you all. Right, we're going to get going with sequences and series. Now, this is a really nice topic that can be taught separately, but it's got some very interesting things about it. And it largely gets put into two different chunks. You've got the first bit, which is about arithmetic series, and then you have geometric series. And then these bits down here we'll talk about in a little bit later on as well. You may know the difference between these already from GCSE. I'm not going to spend too long on it now, because we'll be exploring it as we go through the rest of this anyway, okay? So we're going to start off with arithmetic series. But before we talk about a series, we're going to talk about different types of sequences generally, okay? So the first type of sequence that you'll have come across from GCSE is an arithmetic sequence. So we have something that looks like this, that goes 2, 5, 8, 11, 14, and you can clearly see in this sequence, each time it is going up 3. So we would say that the common difference, this is a new piece of language we might use here, that the common difference for this one is a positive 3, or just 3. If it was going down each time, we would obviously say that its common difference was a negative number instead. So I've written here, an arithmetic sequence is one which has a common difference between terms. Each time it moves along, it's going up or down by the same amount. We've then got a second type of sequence that you might know about. I think you may have seen these at GCSE as well. We've also then got something called a geometric sequence. And a geometric sequence, you can see from this one, it goes 3, 6, 12, 24, 48, 96 would be coming next. And you can see that as you go across this sequence, it is being multiplied by the same number each time. And this number that it multiplies by each time is called the common ratio. And we'll be exploring this later on. And then this last kind of sequence is a very famous one, the Fibonacci sequence, where we have 1, 1, 2, 3, 5, 8. And this is where you take the two numbers that come before, you add them together, and it gives you the next number. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, so the next number would be 13. And I've said this is the Fibonacci sequence. They follow a recurrence relation, and that's because each term can be generated using the previous ones. This is what we call a recurrence relationship, and we encounter these recurrence relationships even later in the chapter after we've done arithmetic and geometric sequences. So that's just a very broad overview of what these kind of sequences look like. But these are not series. You'll notice that this is called sequences and series as a topic, and in a second you'll see that a series is the same thing as a sequence, but it's just got plus symbols in between. Bit of a spoiler. Okay, so some fundamental things about sequences. This u that we have here, if we say un, this is actually saying what is the nth term of a particular sequence. So if I said u3, it would refer to the third term in that particular sequence. And n refers to the position of the term in the sequence. So just get this clear for a second. Un refers to the nth term. It refers to just a general term in that sequence, meaning a term is just like a thing that's in the sequence, which is usually a number. So u3 is the third number in the sequence, and n, the little corner bit, tells you the position of the term in the sequence. So clearly here you can see that this one would be u3, which is equal to 8, and its position number is 3. So if I was going to say what is, whoops, I'm on the wrong setting there, let's just change this over to a pen. So if I said what is u5, well, clearly u5 is the 1, 2, 3, 4, 5th one, which is 14. You could also then tell me that u6 is going to be the next one along, which is 17, just because of how those bits go like this. Let's just quickly erase this. I don't want this here, do I? So we could also say when n is equal to, I don't know, 2. When n is equal to 2, you can see it's referring to this number that you've got here. So it's just a bit of an idea of these, what they are. And I'm sure you could probably do this from GCSE, that the nth term, that un, expressing it in terms of n, I'm not sure how you'd have done this from GCSE, but probably the way I would have done it with my classes is I would say, oh, well, it's going up in 3s, so I know it's 3n, and the previous number would have been -1, so the nth term is 3n minus 1, and you can just check that works with one of these. For example, if n is 5, you'd have 3 times 5 minus 1, which is 15, take away 1, which is indeed 14. So that would be our nth term for this one that we have here. Okay, now we're going to look at the nth term of an arithmetic sequence, perhaps in less of a in a slightly different way to how you might have done it at GCSE. We're going to try and use some different language here, just because it's going to be a bit more powerful than what we've done at GCSE. So with these sequences, we've got quite a new amount of stuff we need to learn, some new terminology and lettering. So here we use a, the lowercase a, to denote the first term, and that's also going to be true with geometric sequences as well. D is the common difference, or the difference between the terms, and we already know that n is the position of the term that we're interested in. So for example, the first term is just a. The second term, well, you'd take the first term and you would add on that difference that you would have here. I don't know, so the example we just had on the previous page was 2, and to find out the next one, you would do 2, you would add on the common difference, and you would get 5, so it goes 2, 5, I think it was 2, 5, wasn't it? Let's have a quick look. Yeah, it goes 2, 5, 8. So it would be, the next one would be 2 plus 2 times the common difference, which is 2 plus 6, which is 8. So you can see how this sequence is working. And then the nth term, well, you have the first term that you would have, and you add on n minus 1 lots of the common difference. So here, for the second term, you're only adding on 1 of the common difference. And for the third term, you only need to add on 2 of the common difference. So the number of common differences you're adding on is always 1 less than the position that you're in. So when you're in the nth position, you're only adding on n minus 1 lots of the common difference. Hence, the nth term of an arithmetic sequence is un equals a plus n minus 1d. And this is something that you are going to need to have to memorize. So I'm going to put this for your memory pages. You need to know how to find this arithmetic sequence. So let's have a quick look with a few examples, and you'll see how this is very similar to things that you'll have done at GCSE. It says that the nth term of an arithmetic sequence is un equals 55 minus 2n, and it says write down the first 3 terms of the sequence and then find the first term in the sequence that is negative. So for part A of the question, we've got here, we want to find the first 3 terms. So we're going to say that u1 is going to be 55 minus 2 times 1, which is just going to be 55 minus 2, which is 53. Gosh, I've only just woken up. And then we can probably do the other ones without actually having to write out all the substitutions. So this time it's just going to be 55 minus 2 times 2, which is 55 minus 4, which is 51. And because it's an arithmetic sequence here, you can spot each time it is just going down by 2. So I know that the next one is actually just going to be 49. Now, we could, if we were in GCSE, it's possible that you might have just kept doing this sequence to find out what is the first term in the sequence that is negative. So let's actually do it in a bit more of a sophisticated way. We want this thing that we have here, which is 55 minus 2n, we want that to be negative, so we want it to be less than 0. So when we solve this equation, we end up with 55 over 2. Yeah, I have just woken up, so I'm going to just use my calculator. I am being so lazy. So we have 27.5. We know that n has got to be greater than 27.5. So we can't say that n is 27.5 because it has to be a whole number. So we say that n has got to be equal to 28. So it doesn't actually say what is the position where it's negative. It actually says what is the first term in the sequence that is negative. So I'm now going to actually have to work out what the 28th term is, which is 55 minus 2 times 28. And I think that's just going to be negative 1, but I'm being super lazy. 55 minus 2 times 28. Yeah, it is negative 1. So that is the first term in the sequence that is negative. Okay? Let's have a look. Another example. So it says find the nth term of each arithmetic sequence. Now, you could find these nth terms using your GCSE knowledge. However, I'm going to try and encourage us to use this new technique because I just think it's going to be more useful as we move across to doing some things with geometric stuff. So my tip here, and it's going to be a tip throughout the whole thing, is to write down the things that you actually know about in this particular situation. So we're going to try and find the nth term of each of these arithmetic sequences. So we can clearly see for question A that the value of A is 6, because remember A is just the first term that we have there, and the value of the common difference is just going to be, well, it looks like it's going up in 14s that we've got here. And we know that un is equal to a plus n minus 1 d. And so we've basically got the answer already because this is the nth term here. So we can just substitute in. We have 6 plus n minus 1 times 14. And this is technically the nth term. However, I think we can probably expand this. So we would have 14n, and you would have minus 14 plus 6, so that's 14n, and you've got minus 14 plus 6, which is minus 8. So this nth term here is 14n minus 8. And if you just think of your GCSE technique of doing this, you would say, oh, well, it's going up in 14s, so I'll do 14n. And if you worked out the number that came before, it would indeed be minus 8. So you can see how it does actually come up with the same thing that you have here. So for part B, we can see that the first term is 101, and the common difference, what do you think the common difference is? Okay, you may think that the common difference is 7, but that is not the common difference. The common difference as we're moving across is negative 7. So when we put this together to find out what un is, it is going to be a plus n minus 1 multiplied by the common difference, which is minus 7. So I'm just going to expand that really carefully. So you've got 100, you've got negative 7 times n, which is minus 7, and then you've got negative 7 times negative 1, which is 100. Oh, what am I talking about, 100? I was going to the next bit, which is just plus 7. So you end up with 107 take away 7n. 107 take away 7n, that's probably what you'd see here. Common difference is 7. That's gone. Oh, I've written this wrong. Shouldn't say 100, should it? Should say 101. I knew something didn't seem very good there. So let's just quickly get rid of this and this and this. My mistake. Wrote my a value down wrong. So we get 108 minus 7n. So yep, the previous number would have been 108, and it's going down by 7 each time. Okay, it says here, a sequence is generated by the formula un equals an plus b, where a and b are constants to be found. Given that u3 equals 5 and u8 equals 20, find the values of the constants a and b. Okay, so let's start off with this u3 being equal to 5. So for u3 being equal to 5, we can clearly see that n is equal to 3. So we can say that 5 equals a plus n minus 1 d. So let's just write that out. We get 5 equals a plus 2d. And then for our second one that we've got, we have u8 is equal to 20. Now that means that n is equal to 8. So we're going to say that u8, which is 20, is equal to a plus n minus 1 d. So we get 20 equals a plus 7d. Now you've probably already spotted what's going to happen with this thing and with this thing that we have here. We've got simultaneous equations that are going to help us find out the first term and the common difference. Now I'm going to subtract these. I'm going to do this one over here, which is number 1, and this one number 2. You could obviously put these on your calculator, but if I do number 1 take away number 2, I've got this take away this, so I get 15 equals 5d, so d equals 3, and then just substituting this into here, that would be 5 equals a plus 6, so a equals minus 1. Now, you just need to be careful about this because a isn't necessarily the values that we have here, okay? So we now know that our sequence is that un is equal to our version, which is a plus n minus 1 d. So this just requires a little bit of some manipulation here. So we end up with, minus 1 plus 3n minus 3. So it ends up as 3n minus 4. Hence, the value of a in their question, which is different to the a that we had before, is 3, and their value of b is minus 4. Okay, perhaps annoying that they've used the letter A here. I don't really think that they should have done, but you just need to put that back in. Once you found out what the sequence actually looks like, you can then find out these things you've got here. And I'm just actually going to work with this and check and see if it does make sense. Let's just do this in a different colour for a second. So here, we've said that the first term is -1. Oh, haven't even changed to a different colour. Let's go back here. So we've said that the first term is -1, and we've said the common difference is, what did we say the common difference was? 3. So it would go -1, it would go 2, it would go 5. Look, the third term is 5, which is good. And you can just keep thinking to yourself if we go up to the 8th one. So it's the 3rd, the 4th, the 5th, the 6th, the 7th, and the 8th one. So we've got it right. There's the third term, which is 5, and there's the 8th term, which is 20. Okay, now of course, they are probably going to want to make these things a bit trickier at A level. So it says here, for which values of x would the expression -8, x squared, and 17x form the first 3 terms of an arithmetic sequence? Well, they would make an arithmetic sequence if the difference between them were constant, if it was a common difference. So I'm going to say this one, take away this one, and then this one, take away this one. If they are exactly the same as each other, then it would be a common difference. You could also do this one, take away this one, and this one, take away this one, as long as they're going in the same direction. But I'm going to just go with the purple one that I had, so I better stick with my purple pen actually. Okay, so I'm going to do x squared, and I'm going to take away -8, and I want that to be the same as 17x, take away x squared. So that becomes x squared plus 8 equals 17x minus x squared, and there it is, a quadratic that we've got. So I'm going to get everything onto one side. So I get 2x squared minus 17x plus 8 equals 0. And of course, I'm going to just go straight to my calculator for this. So that's 2 minus 17 and 8. And so the values of x would be either 8 or 0.5. You could do it the other way around. You'd just come up with the opposite of this. You'd end up with -8 minus x squared, and you'd come up with x squared minus 17x. But when you put it all on one side, you come up with the same quadratic and the same solutions for this. So here we go. We've got this as an exam style question now. It says the second, third, and fourth terms of an arithmetic sequence are 2k, 5k minus 10, and 7k minus 14, where k is a constant. Oh, I don't think I can actually put this one in here, so let's get rid of this. It says show that the sum of the first n terms of the sequence is a square number. We haven't actually done the sum of the first n terms, so let's just leave this bit off for a second. But why don't we instead find out what values of k would make it an arithmetic sequence? So we're going to do slightly different. We're going to do the same thing here. For which value of k would it form an arithmetic sequence? So I'm going to do 5k minus 10 minus 2k. So I'm doing this one minus this one to say what's the difference between them, equals 7k minus 14 minus, careful of your brackets here, 5k minus 10. So we end up with 3k minus 10 equals 7k minus 14 minus 5k plus 10. So that's 3k minus 10 equals 2k minus 4. So you end up with subtracting the 2k, you get k minus 10 equals minus 4, so k equals 6. So if k was equal to 6, that should form an arithmetic sequence. Let's just see if that makes sense. So you get 2 times 6, which is 12, you get 5 times 6 is 30, take away 10, which is 20, 7 times 6 is 42, 42 take away 14 is 28, 42 take away 14. Wow, my brain is not working. So yes, it is an arithmetic sequence, and it's going up in 8. Okay, there is now a question here that I'm going to ask you to have a go at, possibly after you've done exercise 3A, but I'm going to give you a chance to pause this, and then I'm going to have a go at doing this in just a second, okay? So you may like to pause this now, do some of exercise 3A, and then start watching, and then finish watching the video so that I can go through this one. Okay, so in this question it says, Zin has been given a 14-day training schedule by her coach. Zin will run for A minutes on day 1, where A is a constant. She will then increase her running time by D plus 1 minute each day, where D is a constant. Show that on day 14, Zin will run for A plus 13D plus 13 minutes. Okay, let's just pause at that bit there. Let's actually switch to a different colour. So, 14 days, and on the first day, she will run for A minutes. And it will increase each day by D plus 1. So if we can extract some of that information, let's ignore this bit just for 1 second. It looks like that our first term is capital A, and the amount that it's increasing by, the common difference, rather confusingly, D is actually equal to D plus 1. And when I'm saying D, I'm actually just sort of saying the letter D. I'm not actually saying D equals D plus 1, because that's obviously an impossible kind of equation here. So we're going to say that on day 14, we're actually saying, what is U14 equal to? Well, we know it's normally equal to A plus N minus 1D. So let's just say that UN is equal to A plus N minus 1D. So in our case, it is going to be capital A plus N minus 1. So N is the 14th day. So we're saying that N is equal to 14. So we get A plus 13 multiplied by the common difference. In our case, it's actually D plus 1. So you get A plus 13D plus 13, which is exactly what they wanted us to show here. It then says someone else. So we have Yi has also been given a 14-day training schedule by her coach. Yi will run A minus 13 minutes on day 1. Okay, so let's actually now say that A is equal to A minus 13. She will then increase her running time by 2D minus 1 minutes each day. So her common difference is 2D minus 1. Given that Yi and Zin will run for the same length of time on day 14, find the value of D. Okay, so I should find out how much Yi is going to run on the 14th day, which would be A minus 13, which is the A part here, plus N minus 1. Now, N minus 1 is going to be 13, so that's plus 13 lots of 2D minus 1. So just simplifying this, we get A minus 13 plus 26D minus 13. So that's A plus 26, let's erase this, plus 26D minus 26. And we've been told that they will run for the same length of time on day 14. So that means that this thing here must be equal to this thing here, because that's how much they run on the 14th day. So for that part B of the question, I'm going to say that A plus 13D plus 13 is equal to A plus 26D minus 26. So the A's cancel out. I'm going to add the 26 onto that side so that I get 39, and I'm going to subtract 13D so that I get 13D, and so D is equal to 39 divided by 13, which is 3. So the value of D that you should have there is 3. So you can try some questions for me from exercise 3A, and then we're going to have a go at doing some things to do with arithmetic series as well. Okay?